Welcome back. So far we've covered addresses and the services that hand them out and resolve names. Today we learn how one device juggles many services at once, using ports, and we'll memorize the protocol port numbers that come up in Helpdesk tickets every single day. This is one of the most practical lessons in the whole module. Here's the core idea. A single device has just one IP address, but it often runs many services at once: a web server, an email server, a remote access tool. So how does incoming traffic know which one it wants? Port numbers. Think of the IP address as the street address of a building, and the port as the apartment number inside. The IP plus the port together is called a socket. Every port belongs to one of two transport protocols. TCP sets up a connection first and guarantees your data arrives complete and in order. It's reliable, with a little overhead. UDP just fires the data off with no handshake at all. It's fast and lightweight, but there's no delivery guarantee. Web pages and file transfers use TCP DNS lookups, voice calls, and live video often use UDP, because speed beats perfection. Now the part to memorize. 80 is HTTP, plain web traffic. 443 is HTTPS, secure web. 53 is DNS, name resolution. 22 is SSH, a secure remote terminal. 3389 is RDP, Windows Remote Desktop, which you'll use constantly. And for email, 25 is SMTP for sending, 110 is POP3 and 143 is IMAP for receiving. A quick safety note. Some old protocols send everything, including passwords, in clear text. Telnet, on port 23, is the classic example, and you should use SSH on port 22 instead. Plain FTP on ports 20 and 21 is similarly unencrypted, so prefer secure alternatives. On the job, seeing these legacy ports open can itself be a security red flag worth raising. Here's why this matters for troubleshooting. Blocked ports cause very specific symptoms. If secure web pages fail but plain ones work, port 443 might be blocked. If a user can't reach remote desktop, suspect 3389. If email sends fine but won't receive, look at the receiving ports, 110 and 143, not the sending port. Matching a symptom to a port is a core diagnostic skill. Let's see ports for Real. On Windows, netstat-an lists active connections and listening ports. A line marked listening means a service is sitting on that port, waiting for connections. A line marked established means there's an active, live connection right now. It's a quick, powerful way to see exactly what a machine is doing on the network. One more handy tool. In PowerShell, test-net connection lets you check whether a specific port on a remote machine is reachable. Type the host name in -port 443, and it tells you true or false. This is brilliant for proving whether a firewall is blocking you, rather than guessing. If it comes back false, the port is closed or filtered somewhere along the path. Let's recap. Ports route traffic to the right service on a single IP address. TCP is reliable, UDP is fast. And the ports to know cold are 22, 53, 80, 443, 3389, and 25. Your task: write out the protocol and transport type for ports 22, 53, 80, 443, and 3389 from memory. Then run netstat-an and find a listening port, and use testnet connection to reach port 443. See you next time for network hardware.